Hello students, welcome back to e-learning edu. So in today's class we'll be solving the in-text question from the chapter thermodynamics. So the question is, a swimmer coming out from a pool and is covered with a film of water weighing about 18 gram. How much heat must be supplied to evaporate this water at 298 Kelvin? Calculate the internal energy of vaporization at 298 Kelvin. And here the heat or the enthalpy of vaporization for water at 298 Kelvin is given, which is 44.01 kilojoule per mole. So here the things which is given in your question is 18 gram. The weight of the water is given, right, which is 18 gram, and you need to calculate how much heat must be supplied. So here heat how much heat, that is enthalpy, should be calculated to evaporate this water at 298 Kelvin. At 298 Kelvin, how much heat or the change in enthalpy of vaporization or the change in internal energy of vaporization need to be calculated here. So first of all, see how much must be supplied to evaporate this water at 298 Kelvin. So for this, here the water, whatever the water is present, it is getting evaporated, right? So 18 gram of water which is present in the liquid state, is getting vaporized. So here 18 gram of the liquid water is getting to the vaporized state, or that is 18 gram of the gaseous state. So first thing is that we need to convert it into the terms of the mole. So it is given in grams, right? We need to convert it in moles. So water, when we calculate the molecular mass of the water, it will be 1 into that is a mass of water 1 into 2 plus 16 into 1. So we will be getting 18 molar mass of the water is 18 mass. So we have converted it in terms of the molar equation. So after converting it into molar equation, so here what they have asked you to find is the change in internal energy of vaporization. So it is getting vaporized means it will be the change in vaporization, and the U, that is the internal energy, we need to calculate. So we have the equation delta H of vaporization, or the change in enthalpy of vaporization, is equal to change in internal energy of vaporization plus P delta V. But P, and that is the pressure as well as the change in volume, is never mentioned in your question. So what we have to do, we have one equation for the ideal gas, right? That is the ideal gas equation, which is PV is equal to nRT. So we need to use that equation, which is PV is equal to nRT. So instead of this P delta V, we can just substitute it by the equation nRT. So now it will become and since the condition is at the standard condition, so it will be like delta vaporization H that is at the standard condition, equal to delta that is change in internal energy of vaporization plus delta NGRT. We have used the ideal gas equation, that is PV is equal to nRT. So delta vaporization, that is a change in internal energy of vaporization. So we need to find the change in internal energy of vaporization, right? So we are just interchanging or rearranging the equation. We'll be getting delta or change in internal energy of vaporization is equal to change in internal energy of the enthalpy, that or the heat, minus delta NGRT. So change in enthalpy of vaporization is given in your question, which is equal to 44.01 kilojoule per mole, right? So just substitute the values. So delta enthalpy of vaporization is equal to 44.01 minus 1 into, that is 1 means only 1 mole is present. Water, how many moles of water is present? See here, only 1 mole of water is present, right? That, so it will be 1 into and we know the gas constant, the value of gas constant is 8.314, and temperature is since it is at the standard condition, temperature is 298 Kelvin. So when we multiply as well as subtract, we'll be getting the answer, which is equal to 41.53 kilojoules. So that's the answer. So here first before solving the question, you have to see whatever given in your question. See, the water is given, so water, the gram or the weight of the water is given in terms of gram. So we have to calculate the molar mass of the water. Since here only 1 mole of water is given, there is no need to there is no other stoichiometric value, so no need to multiply with any other stoichiometric value. So again, after calculate the molar value or the molar equation, so we have to use the equation. So here we need to calculate the enthalpy change, or the internal change in internal energy. So we can use this equation and then substitute the value. Okay, so I hope you are clear with this problem. So do subscribe my channel and recommend it to your friends. Thank you.